Alright, so here we are in the second part of lesson 3.1. In the first part we got as far as this question at the bottom of the page that says 5 times 2/3, or 5 groups of 2/3. So what I've done is I've taken this rectangle and divided it roughly in 5 pieces. And if we continue the divisions to the bottom of the rectangle, we could think of each of these pieces as one whole value. Now, since the question says 5 groups of 2/3, the defining part of the character is, or the fraction rather, is thirds. And so we're going to divide each of these whole values into 3, something like this. And then we're going to count 5 groups of 2/3. So here's 2/3 from the first whole value. Here's 2/3 from the second whole value, 2/3 from the third, and from the fourth, and from the fifth. And when we add all of those up, we can say 5 times 2/3 equals the total number of thirds there are. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. We could also say this another way. If we think of the whole values, so there's one way of answering the question, and that's correct, by the way. We could think of it in terms of whole values as well. We might say, well, it takes 3/3 to make one whole value. So if we count groups of 3, there's one whole value there. Here's another whole value here. Here's another here, which leaves us only this one left over 1/3 in the corner. So 5 times 2/3 is also equal to 3 whole values and 1/3. This works both with a picture and algebraically, because if we divide 10 by 3, 10 divided by 3 is 3, with 1/3 left over. So what I'm showing you right now is just how to do those multiplication of fractions with the picture, and then later we'll focus more on the numbers without the pictures. Let's go to the next page. Use a rectangle to solve 7 times 1/4. All right, I need 7 groups, so this is going to be a bit of a guess here. Let's see, 1, 2, 3, 4, 5, 6, 7. Not too bad. So we'll divide these into 7 whole values. Something like that. And there's 7 groups of 1/4, so each of those whole values will divide into 4 pieces. Something like that. Now we need 7 groups of 1/4. So from each of them, I'm just going to take 1/4. There's 1/4 from the first, 1/4 from the second, 1/4 from the third, 1/4 from the fourth, from the fifth, from the sixth, and from the seventh. Now I probably should have done this to begin with and labeled these. But you can still see from the picture that 7 times 1/4 is equal to 1, 2, 3, 4, 5, 6, 7 quarters. So there's our final answer. Or if you prefer to think in terms of a mixed fraction, let's group groups of 4 rather. So here's 1, 2, 3, 4. These 4 altogether make one whole value, which leaves me 1, 2, 3/4. So I can say 7/4 is also equal to 1 and 3/4, or 3/4. The next question says, use a rectangle to solve 4 times 5/6. Okay. So groups of 4. I need 4 whole values. Let's go like this. There's 1, 2, 3, 4 whole values. And each of those is going to divide into 6 pieces. So something like this. Sorry, these aren't very even divisions, but the number of divisions is correct. So we'll work with that. And what we're looking for is groups of 5/6. All right, so from the first whole value, here's 5/6, all the way down to this line there. From the second whole value, here's another 5/6, all the way down to there. There's another 5/6 from the third value, and a fourth group of 5/6 there. So when we count up the number of sixths, we've got 5, 10, 15, 20. We can say 4 times 5/6 equals 26. And of course, we wouldn't leave that fraction in as 26. We ask ourselves, what divides into both 20 and 6? Well, we can simplify that a bit by dividing by 2, and we get 10/3. So there's our final answer in simplest terms. Now, if you wanted to think in terms of whole values, there's 6 whole values there, or 5 there, sorry, with a 6th there. So there's one whole value. There's 4, and 2 more give us another whole value. These 2 and these 4 give another whole value. And I'm left with a 6th here and a 6th here. So I can say 1, 2, 3 whole values and 2 sixths, or 3 and 1/3. Last one. It takes Michael 2/3 of an hour to completely assemble one bicycle. If there are 12 bicycles, how long will it take him to assemble them all? Well, this seems a little different at first because it's a word problem, but that's okay. We just have to figure out what it's asking us. So if it takes 2/3 of an hour, you should probably have that underlined already because you recognize that as an important bit of information. 12 bicycles is important, and we have to assemble them all. That's what we're asked to do. So we've got 12 groups of 2/3 of an hour. So 2/3 times 12, or if you wish, 12 times 2/3. Here we go with a big rectangle. I'll just switch to a little thicker line here. Something like that. And we're going to divide this into 12ths. So that would be so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 parts. We'll just illustrate those this way. So we've got a division of 12 whole values, that is. And each of those is split into thirds. So something like this. So what is 12 groups of 2/3? Well, here's 2/3 here, 2/3 here, 2/3, 2/3, 2/3, and so on, all the way across the page. So every one of those whole values has 2/3 used up. And when we add the number of 2/3, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 thirds. So we can say 12 times 2/3 equals 24 thirds. And when we do that division to simplify the fraction, 24 divided by 3 is an even 8. Now, what if we decided to think of this in terms of whole values? How many thirds are there? There's 1/3 there. Sorry, one whole value, one group of 3/3, that is. Here's another group of 3/3. Here's a third group of 3/3. Another here, another here, and here, and here. And in this case, we have no leftover thirds. So we just count the number of whole values we have. We've got 1, 2, 3, 4, 5, 6, 7, 8 whole values, which is what we ended up with using the parts of 3. So let's say this, being a word problem, we have to state our final answer in terms of words also. We can say, it takes 8 hours to assemble 12 bicycles. And that's it. So a few multiplication questions, a couple word problems, and you can finish the rest of the homework assignment.